Hello there, welcome to Chemistry Chapter 1, Lecture 3. In this lecture, we're going to cover pages 22 through 27 in your book. We're going to go over on your own problems 1.13 and 1.14 and a little bit of the homework worksheet. You're going to need your calculator, your notes. We're only going to go over page 4 of your notes, and we're also going to work a couple of problems from your significant figures and scientific notation worksheet, which is part of your homework. All right, so in the book, the first problem you're going to work is on page 25. You'll need a highlighter also. So scientific notation is a method of dealing with very large and very small numbers. Okay, so in chemistry, oftentimes when you're counting things like atoms, there's a lot of atoms, in a small volume, you use a very large number, or if you're dealing with the width of atoms, something like that, atoms are very small, molecules very small, we'll use very small numbers. So we need a method of easily dealing with these very large or very small numbers, and the way we deal with those, it's called scientific notation. All right, so when we get to your calculator, you're going to want to make sure to use the double E button, and I'll show you how to do that, instead of the rooftop or caret button. So I have had students in the past, when they use that caret button, make some mistakes. And if you use the double E button, you'll almost never make a mistake. I'll show you when we get to it how to deal with that. So first of all, we want to do some scientific notation conversions by hand. So let's open up to page 25 in your book. And we'll work 1.1.3. Or excuse me, 1.13. So convert the following numbers into scientific notation. All right, so part A is 26,789,000. So we want to convert that into scientific notation. So this is how you do it. You want to start, for these numbers that are greater than 1, start at the end, all right? And we're going to count how many places that we go until we get to the last digit. So we're going to go 1, 2, 3, 4, 5, 6, 7. So the way that we portray that number in scientific notation, we're going to put our decimal right here. It's 2.6789 times 10, and we went over 7 spots. So times 10 to the 7th. Okay, so that's like saying 2.6789 times 10 million. 10 to the 7th power is the same as 10 million. So we're using the power of 10 to shorten the numbers. All right, and how many significant figures are in this number? Well, it's all of these zeros don't meet the criteria for significant figures. They're not to the right of the decimal point. So it's just 1, 2, 3, 4, 5. And it would be the same thing here. 1, 2, 3, 4, 5. The 10 to the 7th, we don't count those as significant figures. Only those that are in the number there. So that's going to be 5 significant figures. All right, let's take a look at B. So that's 123. So again, we're at a number greater than 1, so our exponent's going to be positive. If you're greater than 1, your exponent will be positive. We start here at the end, and we're going 1, 2 places. So the way you'd write this in scientific notation is 1.2 23 times 10, and we went over 2 places, times 10 to the second power. How many significant figures are there in this number? It's just 1, 2, 3. All right, so we'd have 3 significant figures. All right. Part C, we have 0.00009870. Okay, this time our exponent is going to be negative because our starting number is less than 1. Okay, so we're going to go to the right now, and we're going to end up with we're going to stop our decimal after the first non-zero number. So we go 1, 2, 3, 4, 5. We stop right there after the first non-zero number. So the way you would write this in scientific notation is 9.870 times 10. We went over 5 spots, but again, it was a tiny number, so times 10 to the negative 5 power. All right, how many significant figures? There's 1, 2, 3, 4. This 0 is significant. It's to the right of the decimal and at the end, so we'd have 4 significant figures. All right, and then part D is 0.980. So you tell me, is this exponent going to end up being negative or positive for 0.980? What do you think? All right, the number's less than 1. It's not much less than 1, but it's less than 1. So we're going to the right 1 spot because that's our first non-zero number. So this would be 9.80 times 10 to the minus 1 power. So there's 3 significant figures here, 3 significant figures here, just those. And that's how you would change these decimal numbers to scientific notation. All right. So just remember, your exponent's positive if it's a number greater than 1, negative if the number is less than 1. Okay, so let's take a look at on your own 1.14. We're going to convert the following numbers from scientific notation to decimal form. So this time we're going the opposite direction. So our first one is 3.456 times 10 to the 14th power. So what you do to convert it back to decimal, you're going to start here at the decimal and go 14 spots to the right. Okay? So you're going to get a really big number here. So 14 spots to the right, or places to the right. Okay, so that's 3, and then we're starting our 14th place. 4, 5, 6, and then it's all zeros after that. 0, 0, 0, 0, 0, 0. See, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, so 5 more. All right, what a big number. So that's why we use scientific notation. Try to eliminate all those zeros, and then to get the parentheses, not parentheses, the commas in the right place, we're going to go from the back 3, 3, 3, 3. All right, so that's 100 million billion. Wow, big number. So 3, 4, 5, 6, and then we added 11 zeros to that. So a total of 14 places after the first one. So how many significant figures? Well, it's just going to be 1, 2, 3, 4. All right. So let's do B. B is 1.23. 41 times 10 to the third. So this time we're going to take that decimal and move it 3 places to the right. So 3 places right. Because again, the exponent is positive, so that's a bigger number than 1. 3 places to the right, that's 123. Excuse me, 1234, 1234.1. And that would be 5 significant figures. All right, part C. We've got 3.45 times 10 to the minus 5. Well, if the exponent's negative, that means it's a little number. So we're going to take that decimal and move it 5 places to the left. All right, that 5 tells you 5 places, and the negative says move it to the left. So that would be leading 0, 0, 0, 0, 0, 3, 4, 5. So just counting there, our decimal was originally here, so 1, 2, 3, 4, 5. We've got it in the right spot. And that's 3 significant figures because none of these leading zeros meet the significant figure rule. All right, and then part D, we have 3.1 times 10 to the minus 1. So you tell me what's going to be the final answer here. All right, so write down your guess on the final answer, pause, and then come back to it. Okay, so we're going to move 1 place to the left. So that's just going to be 0.31, and we would have 2 significant figures there. So we moved 1 place to the left. All right, great. So we'll move on and start using this scientific notation in some other problems. So we are at near the bottom of page 4 in your notes, significant figures reporting procedure. All right, so the precision determines how many significant figures that we can report. So if you are adding or subtracting, we round the answer to the least precise measurement. So let me tell you what I mean by that. So we'll do these examples on the notes. So the example on the notes says that we want to add 12.641 to 18.9. So let's go ahead and put that in our calculator, because our calculator is not going to follow the rounding rules. Okay, so 12.641 plus 18.9, that's 31.541. But that's not rounded correctly. Okay, so in science, you have to round correctly. You can't take measurements in the lab and one is in the tenths place and the other's in the thousandths place and go ahead and say that your final answer is accurate to the thousandths place. That's not true. It's accurate to the least precise of the two. And the least precise would be this, which is in the tenths place. So this is the thousandths place, this is the tenths place, so we have to round it to the least precise. So we would have to round this number to 31.5. So since the 4 after the 5 is less than 5, we would round down. Okay, so for adding and subtracting, round to the least precise of the measurements. Okay, So with multiplying and dividing, we round to the least number of significant digits. Okay? So let's do a couple of examples with multiplying and dividing. The first one in your notes is 10.82 times 1.6789. Okay, let's see what our calculator tells us. Now, the calculator's not going to round it right. So 10.82 times 1.6789. So the calculator is going to tell us 18.165,698. All right, so, that's a ridiculous level of precision. So we've got to round it to the least number of significant digits or figures. So how many significant figures do we have in 10.82? Well, it's 4. And 1, 2, 3, 4, 5 significant figures in 1.6789. So we must round to the least of those. So round to 4 significant figures. So our rounded answer would be 18.1. Now the 6 you're going to round up to a 7 because of the 5 is 5 or greater. We round up. So 18.17 would be our rounded answer. All right, let's do one more example, then we'll do a couple from the worksheet. So we're in your notes there right at the bottom on page 4. Let's do 5,400 divided by 16.79827. All right, let's put this in the old calculator here. 5,400 divided by 16.79827. So that's 321 and then a bunch of decimals, right? Just go ahead and write them down. 321.46167.43. Goodness. Okay, well, with division, it's the same as multiplication. We're going to round to the least number of significant figures. So for this one, 5,400, we have 2 significant figures. Right? Those zeros aren't to the right of the decimal, so they are not significant. Well, with this one, all of them, 1, 2, 3, 4, 5, 6, 7 significant figures. So we need to round this answer to 2 significant figures. All right, so take a look at that number, and how would you round it to 2 significant figures? I want you to give it a try, and then I think if you get it wrong, the answer will make sense. Okay, hopefully you gave that a try. The answer is 320. That's 2 significant figures. So we had to round 321 and all of those decimal numbers down to 320. We round down because it's just a 1. And that would give you 2 significant figures. All right, great. So go ahead and get out your worksheet. And I just want to work a couple examples from the worksheet, showing you how to put these in your calculator, because in the past I've had students just have some calculator trouble at the beginning of the year, and then of course they got used to it and got better at it. So we're going to work numbers 1 and 2 from each. All right, so we're going to perform the calculations below. You're going to use your calculator. So number 1 is 6.02 times 10 to the 23rd. That's a really famous number in chemistry, and you'll learn about that in Chapter 5, times 5.67 times 10 to the 6th. So I want to show you how to put this in your calculator. The safest way to do it. Especially if you have a TI-84. So 6.02. Instead of typing times 10, I want you to use the double E button. So you hit the second function, and then where the comma is on my calculator, but double E. So 6.02E 23. That E means times 10 on the calculator. And then times 5.67, do the second function, double E, and then a 6. Don't put a 10. The E means times 10, so don't put any 10s in there. Just E23, E6. Hit enter, and the answer you get, and we're going to round this to 3 decimal places because that's how many significant figures we have. So 3.41 E to the 30th. All right, so we can write that. That's the calculator way of saying that. The better way to write is 3.41. Take that E and write it as times 10 to the 30th. Okay, so that's your answer. Now I'm going to show you in a minute, maybe on the next one, why the times 10 can get you in trouble on your calculator, and why it's better to use that double E button. All right, let's try it on this one. So 6.02 times 10 to the 23rd, and then we're going to divide that by 5.67 times 10 to the 6th. Okay, let's do it the way I told you with the double E button first. So 6.02 second double E to the 23rd. Divide that by 5.67 to the 6th. All right, don't put any 10s in, okay? And that is 1.06. So we're rounding it to 2 decimal places, 1.06. And then E to the 17th. And you don't even have to write the E if you don't want to. That's the same as 1.06 times 10 to the 17th power. All right, so that's the right answer. But let's see what happens if instead of using the E, we use times 10 in this case. So 6.02 times 10, and then you would use the rooftop there, or the caret, to the 23rd. And now we have to hit the right arrow to get out of exponent mode, and then divided by 5.67 times 10, and then hit the rooftop to the 6th, and hit enter. See how it gives you 1.06 times 10 to the 29th? That's because it's using an order of operation, and it's dividing by 5.67 first and then multiplying by 10 to the 6th. So the order of operations get all messed up. In order to get the right answer, we would have to put the whole second part in parentheses. So we'd have to do, let me clear it so you're not confused. We would have to do 6.02 times 10 to the 23rd, then get out of exponent mode, divided by, and you'd have to put the whole denominator in parentheses. 5.67 times, let's delete that. 5.67 times 10 to the 6th, and then we'd have to right arrow and get it out of exponent, and then hit the parenthesis. And now you have the right answer. So see how it's a whole lot more complicated to use the times 10 and an exponent than to just use the E button. If you use the E button, you don't have to worry about parentheses and all that other stuff. Yes, you can get the right answer, but you have to be much more careful. So my suggestion is to use that double E button, and you'll get an answer in the form of E either way. Okay, so the rest of the worksheet will be homework. And then, of course, where you are adding and subtracting and rounding to the appropriate number of significant figures, just look back at your notes at the bottom of page 4 for those. And then the rounding rules, I reminded you down here at the bottom for that. All right, so the homework that this lecture covers, and this may be different than the homework that your teacher assigns, but the homework that this lecture would cover would be review questions on page 35, number 8, practice problems, page 36, number 7 and 8, and then the scientific notation worksheet. All right, that's what this lecture covers. But again, go by what your teacher tells you to do. All right, that's it for this lecture. We got one more in this chapter, and I hope you have a great day.